Welcome to Lunchbox Sessions, bite-sized industrial training.
Hello, this is Carl from LunchboxSessions.com. Welcome to our series on hydraulic system schematic reading. We'll be looking at how symbols are connected to each other and what their relationships are, and how to understand much of the normal machine functions by reading just the schematic diagram. And of course, we'll find out that sometimes symbols don't tell us everything we wish we could know just by looking at the schematic diagram. And sometimes there are frustrating little errors and details that are missing. But quite often, quite a bit about the machine's normal function can be easily interpreted if you have a knowledge of the symbols and what they mean when they're connected together. And of course, we'll be using our very exciting live schematic technology to bring the symbols to life. So let's get started by animating and activating this hydraulic system. I'll bring up some controls so that we can move the parts around and see symbols in action, which I believe is the very best way to learn hydraulic symbol reading. But let's start off at the beginning here by looking at the hydraulic power unit. The hydraulic power unit on most hydraulic schematics is near the bottom of the diagram. So let's zoom in. The power unit for a hydraulic system typically includes the pump, the fluid reservoir, and a number of important accessory symbols. Starting on the left, we see a float switch, used to warn of a low tank level or perhaps shut down the pump. We see two symbols for temperature-activated switches, perhaps one for the cooling system and one for the heating system. We know they are temperature-activated switches due to the mercury bulb symbol on the left side. Another mercury bulb symbol shown here is for a sight glass that lets us see the level of the fluid in the tank, but also the current temperature. The symbol shown here at the bottom, which came from this drawing that is 40 years old, was a bit of an error. The rectangle with a single diagonal slash through it is an electrical solenoid. Two diagonal slashes would indicate a solenoid with two windings. Well, upon investigation, there was no solenoid in the tank. It was the draftsperson taking a guess at what the best symbol would be for a tank magnet, a passive device used to trap iron filings and keep them from circulating. Perhaps that was the best guess symbol at the time. Moving over, we see a diamond shape. Anytime a symbol has the diamond, it indicates a fluid conditioning device of some kind, and in this case, with the dark arrows pointed inward, it lets us know that this is a heating device. It brings heat into the fluid in the tank, and the dark black lines on each side of the diamond indicate that fluid is used to heat and exchange with the fluid in the tank, bring a heat exchanging, but the plumbing for the heating system is external and not shown. Moving over to the right, we see a shutoff valve with the triangles blackened, indicating a normally closed valve. That makes sense for the tank drain valve. Contrast that with the shutoff valve here below the inlet filter and the pump, and we see that the triangles are white, indicating that this valve is to be left normally open. Finishing up in the right corner of the reservoir, we see a symbol, which again is the diamond shape, indicating some type of conditioning device. In this case, the fluid that we're conditioning is air. This is the tank breather. Of course, you see a pair of check valves, and missing from the original symbol are the springs that should be below or to the right of the ball symbol, indicating that there is a spring to keep the check valve closed. And this is a vacuum breaker style of breather cap, where if the pressure inside the tank gets too high, it is vented on the check valve to the right. Or if we build up excessive vacuum in the tank, the check valve shown below the breather symbol is pulled open to draw in a volume of makeup air. But that's not the main device for exchanging air in this system. Shown on a black L-shaped line and off to the right on a separate assembly is a clean vent system. A symbol perhaps you don't see too often, looks a little bit like a pair of accumulators. Perhaps in some regard that's very similar, but just a very simple rubber bladder inside, much like a party balloon, which expands as air from the tank needs to push outward and contracts if air needs to be drawn back in. And such a system, together with the vacuum breaker, basically allows for changes in the tank level without exchanging with the outside air, thus keeping dust and contaminants and moisture problems associated with drawing in outside air to a minimum. Let's move over to the pump assembly, and perhaps we should draw attention to a line with the occasional dash in it. Whenever we see those lines, it lets us know that this group of symbols that is within it are all mounted together on the same physical assembly. So we see a shutoff valve from the tank towards the pump, but before we make it to the pump, we see something called inlet line filtration, which in some regard is a form of straining to filter out large contaminants before they enter the pump, but is not exactly like a strainer in the tank. And then we see a circle symbol with a single triangle pointing outward, and this indicates the pump. And in this case, it's a very simple pump. It's a fixed displacement pump. No controls associated with this pump when we see only that very simple circle. The double parallel line indicates a mechanical connection of some sort, and in this case, it is the shaft from our electric motor to the pump. We see a curvy arrow, and we notice that that indicates the direction of rotation for the shaft. In this case, it typically indicates the rotation for the pump, letting us know that if we looked at the pump from the shaft end, that the pump is meant to turn clockwise. Let's move over to the return line where we see fluid coming back from the pump into the tank, and we see a return line filter, a very simple symbol. A more complete symbol would typically also show perhaps a service indicator to let us know that there is some device that could be seen from the outside to let us know when the filter is plugged. And also, quite often, a bypass check valve is drawn to let us know that fluid moves around the filter once the filter is plugged. Moving down, we see one more diamond shape, and this time it's with the dark arrows pointed outward, and that lets us know that this is a fluid cooler. And we see an electric motor turning a fan blade, so we know that this is an air exchange style liquid cooler, a typical radiator. And on our way back to tank, one last check valve, and fluid is returned to a level below the standard fill point in the tank. That's it for the symbols for the hydraulic power unit. On the next video, we'll have a look at pressure control, and we'll get into the symbols on the valve control manifold above. Thanks for watching.
We have hundreds of interactive resources like this live schematic, so you can try out your wild ideas without blowing anything up. Get started at lunchboxsessions.com.